right now then. I'm gonna have a nerdgasm on the freeway. So, this morning, what I was nerding out about, and I just had to make a video for some reason that I couldn't, was me doing a deep dive on something called Hubble's constant. What the fuck is that, you might ask? Well, I'm so glad you asked, actually. Hubble's constant is a value that deals with the rate of expansion between space, being proportional to the distance between two different points. A bunch of word vomit that I just said that probably makes no sense, but let me break it down for you. Galaxy A and Galaxy B, they are moving away from each other with something called recessional velocity, right? They're receding away from each other at a certain speed in a certain direction. There's a formula for Hubble's constant called V equals Hubble's constant times the proper distance, right? V equals recessional velocity equals Hubble's constant, which is a value I'll talk about in a second, times the proper distance being the distance between 2 points in space at a certain cosmological time. Anyways, what's so cool about this is how fast it is, and the fact that the further away 2 points get, the space in between them is expanding exponentially faster. Galaxy A, Galaxy B, right? Let's do Milky Way galaxy, Andromeda galaxy. How fast is the space in between them expanding away from each other? Hubble's constant is denoted as 70 kilometers per second per megaparsec. What the fuck is a megaparsec, you might ask? A megaparsec is 3.26 million light years of distance, right? So it's just a big ass distance. 70 kilometers per second per megaparsec. So that means for every megaparsec, 3.26 million light years, space expands at 70 kilometers per second. So if we had 2 megaparsecs, it would be 140 kilometers per second. If, and then it just increases. If we want to figure out how fast the space in between Milky Way and Andromeda galaxy is expanding at, we just got to plug these numbers in and find out the distance that Andromeda galaxy is right now, the proper distance. If I remember correctly, it's 2.5 million light years away from us. We convert 2.5 million light years into megaparsecs, which equals 3.26 divided by 2.5 is 0.77. So we have 0.77 of a megaparsec. What is that? 0.77 times 70 kilometers per second is roughly about 54 kilometers per second. So the space in between Milky Way and Andromeda galaxy is expanding at 54 kilometers per second, which is like 3,240 kilometers per minute, or 194,400 kilometers per hour, which is 120,794 miles per hour for us Americanos who can't do anything other than freedom units. So the space in between Milky Way galaxy and Andromeda galaxy, the space itself, the fabric, is expanding away at 121, let's say, 1,000 miles an hour. That's really fucking fast. It's faster than my car can drive, right? Now think of this. I was doing some research on this. Like, I was asking Google, I was like, what's the hypothetical furthest distance or furthest galaxy away from us? Like, how far is the furthest galaxy away from us? Like, one opposite end of the universe to us. And it came back with a number that said 46 billion light years away from us, right? And I was like, holy shit, 46 billion light years. Right now, like, if we freeze time and shine a laser and that laser starts traveling to that galaxy, it'll take 46 billion years to get there. Light. Which is super fucking fast. It moves at, 300,000, about 300,000 kilometers per second. I was like, okay, well shit, since that's so far away, and since space expands proportional to the distance, how fast is space expanding in between us and that said galaxy, right? Did a little bit of math, a little bit of nerdy shit, right? And I figured out that space is expanding in between us and that theoretical galaxy at over 900,000 kilometers per second, which is 3 times faster than the speed of light. But Brian, I thought nothing could expand faster, or nothing can move faster than the speed of light, right? You're right. Nothing can travel through a vacuum at the speed of light, or faster than the speed of light. But the vacuum itself can do whatever the fuck it wants. Nothing can travel through a distance faster than the speed of light. But space is the distance. It doesn't have to follow any fucking rules it doesn't want to. I mean, so it's going 3 times faster than light can travel. So that means that if you shined a laser at it, that light will never get there because space is expanding faster than it can get there, right? It's like someone running 20 miles an hour on a treadmill that's going 25 miles an hour, right? You're eventually going to be losing the battle there. Absolutely mind-blowing, because what this means is since everything is expanding, that means that every galaxy pretty soon is going to be so far away from us that the space in between us is going to be expanding faster than light can get to us. So what does that mean? That means that theoretically in a million or billion years, if we're still here and we're looking up at the night sky, we will see nothing. No stars from no galaxies from anywhere in the universe. It's just going to be pitch black aside from our own local group. That really made me think, because I feel for those people. That is going to be a lonely ass universe. Imagine being born into a dark universe and thinking that, shit, this is it. We're just floating on this planet. And outside, absolute nothingness, just darkness. If that isn't the most mind-blowing thing that you have ever heard, I don't know what is. Meanwhile, I've been talking all this nerdy shit, and I've probably moved like 20 feet in Seattle. Fuck traffic.